Good morning, it's Tuesday the 2nd of June. Now this is the solutions to the work that I gave you over the weekend. Your lesson is on a separate video, okay, so this video is entirely the solutions for the exercise that I gave you. Okay, so I asked you to do exercise 2, so we've got to find the coordinates of stationary points, find the nature of each stationary point, and find the intervals and where the curve is increasing or decreasing. Okay, so I did question 5 with you last day, so I'm now going to do question 1 with you. So question 1, fx is equal to x squared plus 1. So that really just means y is equal to x squared plus 1. Right, so the first thing I want to do is I want to find the stationary points. So stationary points occur when dy by dx, or f dash x, is equal to 0. Okay, underline that. Right, so dy by dx for this curve is equal to, take the derivative of that is 2x. So therefore 2x derivative has got to be equal to 0. Divide by 2x is equal to 0. Now we want the stationary point, so I know it's the point 0 something. I want the y coordinate. Y is equal to x squared plus 1. So when x is 0, it's 0 squared plus 1, which is equal to 1. So we have a stationary point, which is at the point 0, 1. Now the next thing I wanted to do was find out the nature. So we do a nature table. And I know that I've got a stationary point sitting at x equal to 0. So x values go in there. I'm going towards the stationary point and I'm going after it. And I've got dy by dx, and I'll put in the formula for that so we can see it clearly. Derivative was 2x. Now I want to find out what's happening before x equal to 0. So take x equal to minus 1. After it, take x equal to 1. So we know at the stationary point dy by dx is 0, so that goes in there. So if we've got x equal to minus 1, dy by dx is 2 times minus 1 is minus 2, so it's negative. If x is 1, 2 times 1 is 2, which is positive. So therefore what we've got is we've got it sloping downhill, going across the way and uphill. So I've got a minimum turning point. And that minimum turning point is at the point 0, 1. Now the other thing you were asked to do was to find out where it's increasing and where it's decreasing. So you draw an x-axis, and on that x-axis we'll pull down the stationary point. So we've got a stationary point sitting there, and that's where x was equal to 0. Now look at the signs for the derivative. The signs for the derivative are all negative in there. Then it comes to x equal to 0, the derivative was 0 itself, that's the stationary point, and then it became positive. So therefore, it's increasing when it's positive. So it's increasing, and we've got to describe all of those x values. So it's from x equal to 0 onwards. So it's increasing when x is greater than 0. Now decreasing means that we're looking for all the wee negative signs. So it's decreasing when, and the negative signs go that way, so they're going less than x equal to 0, so it's when x is less than 0. Okay, question 2. So stationary points occur when, and I'll just keep it as f dash x, when f dash x is equal to 0. Right, underlined. Work out f dash x, so f dash x is equal to, derivative of 3 is 0, multiply by the power, take 1 away from the power, is minus 4x. So a stationary points occur when minus 4x equals 0, and if minus 4x is equal to 0, divide by minus 4, x is also equal to 0. Right, so I now know that I've got a stationary point sitting at 0 something. I want to work out what the y coordinate is. So we know then that y is equal to 3 minus 2x squared, right? So I've just changed the fx to y, it's just the same. So that's going to be 3 minus 2 lots of 0 squared, which is still 0. So the y coordinate is 3. So we've got a stationary point sitting at the point 0, 3. Right, now we need to work out what the nature is for this turning point. So draw your table and put your x values across the top. So we've got a stationary point sitting at x equal to 0. That's the x values. And dy by dx, the formula for dy by dx is minus 4 times x. Right, so I want to know what's happening before this x equal to 0, so pick minus 1. I want to know what's happening after it, pick x equal to 1. Right, so stationary points, we know the derivative is 0. So when x is minus 1, I'll get minus 4 times minus 1 is plus 4, so it's plus. When x is 1, minus 4 times 1 is minus 4, it's negative. So positive slopes uphill, 0 is across, and negative is downhill. So I've got a maximum turning point, and that maximum turning point was at the point 0, 3. Right, now I need to find out where the curve is increasing, where it's decreasing, so draw your x-axis in. Pull down your stationary point, so there was a stationary point sitting here, and again it's x equal to 0, and this is just a coincidence that they're all the same in this exercise to start with. Right, so what's happening before this? It's all pluses, so derivative is all positive, and after that the gradient of the tangent of the derivative is negative. So I've got to describe this bit here, and that's where it's increasing. So it's increasing when we've got the wee plus signs, and that's x equal to 0, so that must be when x is less than 0, and it is decreasing, it's negative, it's going downhill when x is greater than 0. Okay, question 3. Fx is equal to x to the power of 3. So stationary points occur when f dash x is equal to 0. State it, underline it. Right, so now work out f dash x. So f dash x is equal to, multiply by the power, take 1 away from the power, is 3x squared. Stationary points occur when that's equal to 0, so 3x squared equals 0. Divide by 3, so x squared is 0, divide by 3, which is still 0. Square root of 0 is 0. Right, so I've got a turning point or a stationary point at the point 0 something. I want to know what the y-coordinate is. So that's the same as y is equal to x to the power of 3. 0 to the power of 3 is still 0. So a stationary point is sitting on the origin. Right, now I want to know the nature, so draw your nature table, and we've got, again, x is going towards 0 and going away from 0. Turning point is at 0 again in this one. So a value less than 0 is minus 1, a value greater is plus 1. And f dash x, I'll write in the formula just to remind myself, is 3x squared. So when x is equal to minus 1 squared is plus 1, 3 ones are 3, so it's positive. At the turning point, we know it's 0. When x is 1 squared is 1, 3 ones are 3, it's also positive. Right, so it's sloping uphill, then it's sloping across, no slope at all, and then sloping uphill again. So what we've got then is we've got a point of inflection. Okay, and that point of inflection is at the point 0, 0. Right, now the last thing I want to do is I want to find out where it is increasing and where the curve is decreasing. Draw your x-axis underneath that. And once we've done that, we'll look at a table of sines. So that's the x-axis. And I know that the turning point is there when x equals 0 once again. And if I look at the sines, it's positive all the way along there. But then it was 0 at the stationary point, so this is dy by dx or f dash x, okay? And then it became positive again. So this positive bit, I can't just say it's all of that because that broke it. Now, f dash x is equal to 0 as a stationary point there. So there's two sections where it's increasing. So it's increasing when this section here would be x is greater than 0. And it's also increasing when x is less than 0, but it's not increasing at x equal to 0. That's your stationary point. Okay, question 4. So stationary points occur when f dash x is equal to 0. Underline it. Now this repetition will help you remember what you're doing. Right, so f dash x is equal to derivative of 3x is 3, derivative of that minus x to the power of 3 is minus 3x squared. So that thing has got to be equal to 0. Okay. Now, to do this, you can either factorise that side or you can just do it straightforward by adding 3x squared onto both sides. So I'll do that. So 3x squared is equal to 3. Divide both sides by 3. So x squared is equal to 1. And the square roots, remember when I take a square root, I've got two roots. I've got plus 1 and I've got x equal to minus 1. So we've got two stationary points this time. So I've got a stationary point at 1 something and I've got another stationary point at minus 1 something. Okay, we want to find the y coordinate. So we'll do y is equal to 3x minus x to the power of 3. So when x is equal to 1, then y coordinate there is going to be 3 times 1 is 3 minus 1 to the power of 3. So that's 3 minus 1 is 2. When x is equal to minus 1, the y coordinate is equal to 3 times minus 1 minus 1 to the power of 3. Okay, so 3 times minus 1 is minus 3, and then I've got to take away minus 1 to the power of 3. So that's minus 1 times minus 1 times minus 1, which is also minus 1. So that would be minus 3 plus 1, which is equal to minus 2. So we've got our two stationary points. Now we need to look at the nature. So first stationary point, and you go from the first one you'd meet on the left-hand side, so the lowest number of x. So the lowest number of x is the one at minus 1. So we want to find out what's happening before that, what's happening after it. Then we head towards the one where x is equal to 1 itself. Right, so I want a number less than minus 1. We'll choose minus 2. I want a number between minus 1 and plus 1. The easiest one to use is 0. And a number bigger than 1 is plus 2. Right, so at the stationary points, I know f dash x is 0. And now I want to find out what's happening at those other numbers. So f dash x, to remind me, was 3 minus 3x squared. Right, so if x is equal to minus 2, that's going to be 3 minus 2 squared is plus 4. So 3 fours are 12, so it's 3 take away 12, that's going to be negative. When x is 0, that'll be 3 take away 0, so it's going to be positive. That's exactly the same. And when x is 2, it's 3 take away 3 times 2 squared, which is 4. So 4 3s are 12, so 3 take away 12, again, is going to be negative. Right, so look at the shape. So we have got sloping downhill, going across, going uphill, going across, and going downhill. So we've got a minimum turning point at point minus 1, and I've forgotten the y coordinate, minus 1, minus 2, and I have a maximum turning point, and that one is at the point 1, minus 2. Okay, to find out where the curve is increasing and where it's decreasing, I've pulled down the two stationary points. There's a stationary point at x equal to minus 1, a stationary point at x equal to 1. Right, so the other side of this x equal to minus 1, f dash x is negative. Then it's 0 when it gets to the stationary point. And in between all of this part here, it becomes positive, so the curve is increasing. And then it's 0 again at that stationary point, and then it becomes negative again. Okay, so I'm just pulling all of that down. Right, so it's increasing, and I'm looking for the bits where we have positive signs. So it's increasing in between those two bits. So it's increasing where x is in between. So I'm writing the x in between minus 1 and 1. So that's the x in between minus 1 and 1. And the signs go like that because it's less than 1. Both signs have always got to be in the same direction. Right, now I want the areas where it is, or the sections where it's decreasing. Okay, so it's decreasing when f dash x is negative. So it's negative in that section, so that's going to be when x is less than minus 1. And it's decreasing in that whole bit there, and that's going to be the parts where x is greater than 1. I did question 5 with you when I was doing the lesson, so I've missed that one out, and we're now on question 6. So stationary points occur when f dash x is equal to 0. Underline it. Okay. Right, so f dash x for this one, f dash x, and derivative of x to the power of 4 is 4x to the power of 3. Derivative of minus 2x squared is minus 4x, and derivative of 5 is 0. Right, so we've got to then make that derivative equal to 0. So we've got 4x cubed minus 4x is equal to 0. So keyword here is to factorise to solve this. Okay, so if we look at it, there's a highest common factor of 4x, and when I pull 4x out of that, I get x squared minus 1. Now look at that. That's a difference of 2 squares. So I've got 4x, make 2 identical brackets for the difference of 2 squares, take the square root of x squared, which is x, take the square root of 1, which is 1, and make both brackets 1 positive and 1 negative. Right, so in this one, we've got 3 stationary points. So we've got a stationary point where 4x equals 0. Okay, that would make x equal to 0. I've got a stationary point where x plus 1 equals 0. Add 1 onto both, or sorry, take 1 away from both sides, so x is equal to minus 1. And x minus 1 equal to 0. Add 1 onto both sides, so x is equal to plus 1. Right, so stationary point is going to be 0 something, it's going to be minus 1 something, and it's going to be 1 something. Right, so you want to go and substitute into this expression here. So y we know is equal to x to the power of 4 minus 2x squared plus 5. Okay, so when x is equal to 0, that will be 0 to the power of 4 minus 2 times 0 squared plus 5. That will be 5. You can use your calculator if you need to. That's 5 in there. Okay, when x is equal to minus 1, and I'm going to write this one out, so x equal to minus 1. So y is going to be equal to minus 1 to the power of 4 minus 2 times minus 1 squared plus 5. So if you have got an even power, it's going to be positive, because minus 1 times minus 1 is plus 1, and you've got that again. So that is going to just turn out to be 1. Minus 1 squared is also 1, but minus 2 times plus 1 is minus 2, and we've got a plus 5. So that's going to be 1 plus 5 is 6, take away 2, it's going to be 4. So when x is minus 1, the y coordinate is 4. Okay, last one, when x is equal to plus 1, then we've got y is equal to 1 to the power of 4 minus 2 times 1 squared plus 5. So 1 to the power of 4 is 1. 1 squared is 1, so that's minus 2 and plus 5. So 5 and 1 is 6, minus 2 is 4. So 4 again for that. Right, so we've now got 3 stationary points for this one. Okay, so draw your table, section it into 3 bits for your 3 stationary points. So there's 1, there's 2, and there's 3. Right, so x numbers go at the top. Okay. Right, so first stationary point, the lowest x value is minus 1, so we've got minus 1 in there. The next one is at x equal to 0, and the third one is at x equal to 1. So I want to know what's happening before that. I want to know what's happening after it. And likewise for that one and that one. Right, so we want to choose a value of x which is less than minus 1. So minus 2. I'll put in there. Now I want a value between minus 1 and 0. Unfortunately, I'm going to be forced into doing minus a half. Okay, and I want a value between 0 and 1, so I'm going to be forced into doing a half plus a half in there. A value greater than 1 will make that equal to 2. Right, so stationary points, I know that f dash x, I know that that's equal to 0, it's equal to 0, and it's equal to 0. Right, so the derivative for this one was 4x cubed minus 4x. Okay, and we want to know what's happening when this is minus 2, or minus 1, sorry, when x is, no, sorry, it is minus 2, when x is equal to minus 2. Okay, so when x is minus 2, we've got 4 times x to the power of 3. So x to the power of 3 is going to be minus 2 to the power of 3 is minus 8. Minus 8 times 4 is minus 32. And minus 4 times minus 2 is plus, so it's going to be negative. Now, write it down, stick it in your calculator. Right, so when x is a half, a minus a half for this one. Okay, so I'm going to write this one out. So we've got f dash x, and I want to work out when x is a half, or sorry, minus a half. Right, so we've got 4 times minus a half, all to the power of 3, minus 4 times minus a half. So that would be 4 times, that's going to be minus a half to the power of 3, minus 1 to the power of 3 is minus 1, and 2 to the power of 3, 2 2s are 4, 4 2s are 8. Okay, and minus 4 times minus a half is going to be plus 2. Right, so this wee bit here would be minus 4. 4 times minus an eighth is minus 4/8. That's the same as minus a half. So minus a half plus 2, that's going to be positive. And that makes that positive. Okay, right, now we'll do it when x is a half. So f dash x would be 4 times a half to the power of 3 minus 4 times a half. So a half to the power of 3 is going to again be 1 over 2 2s are 4, 4 2s are 8, minus 4 times a half is going to be minus 2. Okay, so what does that give me? Okay, so that's going to be 4/8. So 4/8 is the same as a half, so a half minus 2, that's going to be negative in there, so therefore negative in there. Right, when x equals 2, I'm going to just do that in my head. So 2 to the power of 3, 2 2s are 4, 4 2s are 8, 4 8s are 32, so it's going to be 32 minus 4 times 2 is 8, so it's going to be positive. Okay, I'll get rid of all of this just now so I can see what I'm doing. Right, now you can put all of that into your calculator. Okay, so you don't need to worry about that. Right, so it's sloping downhill, across and uphill. It's sloping uphill, across and downhill. It's sloping downhill, across and uphill. So that means that I've got a minimum turning point, and that minimum turning point was at the point minus 1, 4. I've got a maximum turning point, and that maximum turning point was at the point 0, 5. And I've also got another minimum turning point, and that minimum turning point was at the point 1, 4. So I've drawn the x-axis and I've pulled down the stationary point. So f dash x, then I note that stationary point was 0, it's 0 there, and it's 0 there. Now look at the signs, it's negative. And here all the way across it's positive. And in here it's all negative again. Okay, and at this part here it becomes positive again. Okay, so there it's there, positive. Right, so increasing, I need to find out where it's increasing, and it's increasing at the bits where we have wee plus signs. So where is it increasing? This area here. So that area there is x, all the x values in between minus 1 and 0. So x is in between minus 1 and 0, but it was less than the 0, so you put it like that. It's also increasing at this bit here, and that's where x is bigger than 1. It's decreasing, so it's decreasing when we've got the wee negative signs. So the negative signs, that one first of all up here, is where the x values get less than minus 1, so x is less than minus 1. And it's also decreasing in here, so it's decreasing where x is in between 0 and 1. So 0, it's in between 0, it's in between 1, and the arrows always go like that. Okay, so number 7, so stationary points occur when f dash x is equal to 0. Okay, so f dash x, for this one, derivative of x to the power of 3 is 3x squared, and derivative of 3x is plus 3. Right, so that's got to be when the derivative is 0. So we've got 3x squared plus 3 equals 0. Add 3, take 3 away from both sides. So 3x squared is going to be equal to minus 3. Divide by 3, x squared is going to be equal to minus 1. Right, we've got a problem. You cannot take the square root of -1. So that can't be done. So what that means is this thing has got no stationary points. Okay, so we can't work that out. So there's no x value, so there's no stationary points. Now, I want to think about f dash x, okay, because we want to know if it's increasing or it's decreasing. So if we look at f dash x, no matter what value I put in there for x, whether it's positive, whether it's negative, or whether it's 0, I've still got this plus 3. So if that was 0, f dash x is 3. If it was, say, minus 1, it's 3 ones are 3, plus 3 is 6, it's positive. If it was minus 1 squared is still plus 1. So because every number squared is positive, that's got to be 3 times a positive number, which is positive, plus another 3, which makes it positive again. Right, so it always has f dash x, which is positive. So therefore, it's increasing for all values of x. Okay, it's a wee tricky one there, okay? So you would just check your work if you were doing that one, and you'd say, all right, okay, have I done anything wrong? No, so therefore no stationary points. Unlikely you would get one like that in an exam. Okay, last one, question 8. So question 8, we start off again, stationary points when f dash x equals 0, underline it, f dash x is equal to 5 times 3 is 15x to the power of 4. 3 times minus 5 is minus 15x to the power of 2, and that is 0. So therefore 15x to the power of 4 minus 15x to the power of 2 equals 0. Factorise. Highest common factor is 15x squared. That will leave me with x squared minus 1 equal to 0. That there stays as it is, and the bracket is a difference of 2 squares, so make 2 identical brackets. Make sure you always keep this 0 down here. So x and x, square root of 1 is 1, one bracket is positive and one bracket is negative. So we've got 3 stationary points again. So we've got a stationary point when 15x squared equals 0, or when x plus 1 equals 0, or when x minus 1 equals 0. So that would give me x equal to 0, that would give me x equal to minus 1, and that would give me x equal to plus 1. Right, now we want the actual coordinates. So it's 0 something, it's minus 1 something, and it's plus 1 something. Right, so go back to find out what the y coordinate was. So y is equal to, and I'll write it here so I can see it, y is equal to 3x to the power of 5 minus 5x to the power of 3 plus 2. Right, when we substitute 0 into that, that'll be 0, and that is 2. So we've got a stationary point at the point 0, 2. Right, next one, we'll have got x equal to minus 1. So when x equals minus 1, y is going to be equal to 3 times minus 1 to the power of 5 minus 5 times minus 1 to the power of 3 plus 2. So minus 1 to the power of 5 is minus 1. 3 times minus 1 is minus 3. Minus 1 to the power of 3 is also minus 1. Minus 1 times minus 5 is plus 5. And we've got a plus 2. Okay, so therefore we've got 5 plus 2 is 7. 7 take away 3 is 4. So I've got the stationary point here at 1, 4. Right, when x is equal to 1, I need to sub this in as well. So y is equal to 3 times 1 to the power of 5 minus 5 times 1 to the power of 3 plus 2. Right, so that's going to be 3 minus 5 plus 2. And when I add all of them up, I get 2 and 3 is 5, take away 5 is 0. Okay, so that's all our stationary points. Right, I'll get rid of all of that away from there just now. All the y coordinate working so I can see what I'm doing. Right, so now I want to work out the nature of these stationary points. So draw your table. There is 3 turning points. Split your table into 3 sections. And top section has got to be x. We've got a stationary point. The lowest one is at -1. The next one is at 0. And the last one is at 1. I want to know what's happening before it, what's happening after it, before it, after it, before it, and after it. Right, so for this one here, we have f dash x, and f dash x is equal to, and it was equal to 15x to the power of 4 minus 15x squared. Now there is a way of working out science by just looking at the brackets, okay? Teacher, maybe once you've had a wee bit more experience doing them next year, will show you what you're doing for them. Right, so we've got 0 in there, 0 in there, because they're all turning points, so f dash x is 0 at them all. A value less than -1, -2. A value between -1 and 0, I'm forced into using -1/2 again. -1/2. And here, between 0 and 1, I'm forced into using 1/2. 1/2, and I'd have to go with 2. Right, so we need to sub these things in. Okay, so if x is -2, -2 to the power of 4 is going to be 2 2s are 4, 4 2s are 8, 2 8s are 16, so it's 16 times 15 minus 15 times 4. Okay, so that there is going to be positive. For the one where x is equal to -1/2, we'll work that out at the side. Okay, so f dash x is equal to, okay, so that one will be 15 times -1/2 to the power of 4 minus 15 times -1/2 squared. Right, so -1/2 to the power of 4, -1 to the power of 4 is going to be 1. And 2 to the power of 4, 2 2s are 4, 4 2s are 8, 2 8s are 16. And this one is going to be minus 15 times -1/2 squared. -1 squared is going to be 1, 2 squared is 4. So that is going to be 15 over 16 minus 15 over 4. Right, so that is going to be negative. When x is equal to 1/2, do the same thing. So x equal to 1/2. So f dash x will be 15 times -1/2 to the power of 4 minus 15 times, I'm doing +1/2, right? So it should be +1/2 in there, not minus. I've done minus. Okay, and minus 15 times 1/2 to the power of 2. Right, so 15 times 1 to the power of 4 is 1 over 2 to the power of 4. 2 2s are 4, 4 2s are 8, 2 8s are 16. And that's going to be minus 15 times 1/4. Right, so that is 15 over 16 minus 15 over 4. So that one is also going to be negative. That will be negative. If x is 2, so 2 to the power of 4 times 15 minus 15 times 2 to the power of 2 is going to be positive. Right, so uphill, across, and downhill. So I've got a maximum turning point, and that maximum turning point is at the point -1, and I think the y coordinate was 4, yep. And that's going uphill. No, it's not going uphill, it's going downhill, it's negative. Right, so that one is going downhill, it's going across, and it's going downhill. So we've got a point of inflection, and I'll abbreviate it to a PI. And that point of inflection was at the point 0, 2. And this one here, it's negative, so it's going downhill, across, and uphill. So we've got a minimum turning point, and the minimum turning point here is at the point 1, 0. Okay, to see where things are increasing and decreasing, I've put in the turning points there. There's the X values, and I've put in all the signs, so positive before that one, negative all the way in between there, and then negative again between there. Right, so we'll do increasing, so we're looking at the positive ones. So increasing, we've got this bit here, and we've got this bit here. So that whole bit there is going to be where X is less than -1. And this whole bit is going to be where X is greater than 1. Right, decreasing, there's two sections as well. Okay, and again, we can't just go from there to there because it's 0 in between. Right, remember f dash x is 0 at your stationary point. So this wee section in here is X is in between, and where is it in between? It's in between -1 and 0. And arrows always go that way. And in here, we've also got this bit here, and it's in between two values. It's in between 0 and 1, and the arrows go that way. Okay, so that was quite a long exercise for you to do. Okay, so that's all of the solutions, all of the answers to that exercise. So because it was quite a lot, I posted it on a different video from your lesson. So go through that, check your answers, and do your lesson for today as well. It's on a separate video. Right, well done.